What's up, everybody? Today is February 26th, 2025. We're going to do our daily Leetcode. I attempted to think about this problem earlier, but I'll explain it once we get to the problem. Let's go ahead and warm up with our typing erasing. That was long. Okay, let's just go to the problem. Okay, here's the problem. 873, length of the longest Fibonacci sequence. A sequence, x1 through xn, is a Fibonacci-like if n is greater than or equal to 3, and x plus 1 plus x, or xi plus xi plus 1 equals xi plus 2. For all of I plus 2 is less than or equal to n. This is within the Fibonacci sequence, or the subsequence, right? So when you pick your numbers, it's within that. Okay. Now, I did look at this problem and read it beforehand, and I couldn't come up with a solution earlier. I didn't even type anything, really. I was just thinking about it. So I do have an idea that I want to try. And it's kind of a DP-esque solution, I guess, because we are saving the information. But let me just explain. So I'm going to iterate through the two numbers that we're going to be using, right? Okay, and so every time we see an array, we get some kind of thumb value, right? And we know that we want the two numbers in the array to equal some number later on in the array, correct? So what I'm thinking is that we check for the two values in the array, have the sum, and then say, hey, this values exist. Let's check some kind of cache that we have, right? And if there is that value already in the cache, we're going to increase the length by 1 in that cache, right? Because we do know that there is another solution, which is the triple for loop. But with a triple for loop, it's going to TLE for sure. So I'm just kind of trying to bring it down to more of a n squared plus the lookup of whatever the set is, or what I'm going to do is a pair, or a pair in a map, right? So we're going to do, we want the sum value and the length, right? Because I could do a set, but it wouldn't make any sense. It would just be a map anyway. Right. So we're going to just say if the sum exists, so we're going to go sums length dot find array I plus array j. If this value exists, does not equal sums length dot end. Okay, So if the sum value exists, we want to insert into the new, hold on. We want to insert the new value into the map, right? So we're going to go sums length, and we're going to say array I plus array j. And we want this to equal the value that's in there now. Right? Oh, wait, no, hold on. We look for the sum of the two. Oh, wait, hold on. No. That's not what I meant. I want to look for the values. No. We have a sum. Right? We want to know if we're going to see this sum later as a solid number. So what we want to find is... Wait, no. Is J... Hold on. I broke my concentration. Do you see where I'm going with this, though? So say if we have 1 plus 2, right? One plus 2. Wait, hold on. What if we had an unordered set and we have the sum here, right? If there is a 3, so if we have 3, then 1 plus 2 being 3, that's a length of 1. Or that's a length of 3. Okay. But then how would we do 5? If we were on 2 and 3, does 5 exist? We would say yes. 5. But then how would we get the total length? Is it the maximum of one of these? Sum of 1 and 2 is equal to this. Then we need the sum of 2 and 3. 3 came from here. This is the base. If we have 3 and 5, 2 came from here. Or 3 came from 1 and 2. 5 came from 2 and 3. But how do we get the sum then? We have the sum. We want to see if the sum is in here. Wait, the sum is never going to be in the value. Three plus 11 is 14. What if I just use the maximum? So if I say I feel like maybe it has to be here instead. Oops. Something like this. So it resets the map every time. And we hit the sums. We say 1 and 2. You put 3 into the thing. Okay, then you go 1 and 3. We had that. We have this value. 2 is down in there. This is 3. 1 and 3 is 4. Oh, I don't get it. I don't know how to do it. Thought I knew, but I didn't. Okay, so x1 plus x2 equals x3. Right. the sum of the two, 1 minus 3 equals 2. One plus 2. Okay, I lost it. I was kind of thinking if you stored an intermediate result, then you could just accumulate the length, but it's not working the way I wanted it to. Like if I said something like 1 plus 2, or 1 plus 2 is equal to 3, right? And 3 is a length of 3. Right here. The longest length for this is 3. Okay. Then when you found the next value, it would need to be 2 plus 3 equals 5. And the next value is 3 plus 5 equals 8. One plus 2. Is there a way to do it that way? Like have like a... Found 1. Then I found... Okay, so I have the sum of these two. 1 plus 2. To continue on, I need a value of 3. Which would require a third for them. It's not what I want. At that point, we'd need some kind of previous character or number to recursively call on, right? So what if I, instead of doing... So I have an unordered map, and I say the sum is 3. Oh, wait, so we have I is 1, right? Then what we're looking for is 2 and 3. So in J, if we found 2, we want to store 2 and 3. So if we found 3, then we want to store 3 and 5 because of the addition. Oh, I don't know. I can't think of a good way to do this. I could do something like DFS, right? But then you'd be searching OVN quite a few times. It's almost backtracking at that point. I mean, we know the numbers we're looking for, right? 1 plus 2 equals 3. 2 plus 3 equals 5. 5 plus, or 3 plus 5 equals 8. What happens if I just did this? we just store all of them in a set. The 1,000 numbers, right? Okay, we just throw everything in a set. Okay. We go into the first two numbers. Previous, current. Well, the previous plus current does not equal this. We want then the previous to equal the next current, and current to equal the sum of previous plus current, right? Let's see. So we're on 1, 2. Does 3 exist? Yes. Then we want the sum of 1 and 2 to be current, and the previous to equal 2. Right. And then we're gonna go previous equals C. Okay, so we want the new current equal to previous plus C. So when they add the previous to the current, and we want previous to equal the original current, add the length, and say result equals the max result length. I don't know if this is going to work too well, though, at 1,000 numbers. And it's going to check everything, so array, output is 1. What? Okay, this equals 5. 1 plus 3 are the current values. Okay. us.find. How's it a length of 1? Yeah, we basically go to the end. Oh, never insert the values. Oh, wait, I don't need to. Hold on. Previous plus current. Ray I and Ray J to start. So 1 and 3. Does 7 exist? It does. Oh, wait, this needs to start out at 2. This is 7 now? How are you 7? Should I have the length equal to here instead? Instead of on I? So I'm going to TLE. No, but it's wrong. 2 plus 4 is 8. 8 exists. 4 plus 8 is 12. 12 doesn't exist, and when it doesn't exist, it's done. Okay, so it goes 2, 4, 8. Okay, then we go 2, 7, which is 9. 7 and 9, which is 16. 9 and 16. Do we have a 16? No, we don't have 16. So 2, 7, 9. Okay. Two, 8 is 10. 8, 10 is 18. 1, 2, 3, 4. This is 28, which doesn't exist. 2 and 9 is 11. Nope. 2 and 10 is 12. Nope. 2 and 14. Nope. 2 and 15. Nope. 2 and 18. Nope. 2 and 23. Nope. 2 and 32. Nope. 2 and 50. Okay. 4 and 7 is 11. No. 4 and 7. It just breaks if it's not there. Okay, how can we do this in a way? So if I do something like I know those work, but let's try this. Okay. So we have 2 and 7, 2 and 7, which makes 9. 9. Previous plus current. 2 plus 7 is 9. Okay. 2 plus 7 is 9. Wait, that can't work. Um, 2 plus 7 is 9, right? 2 plus 7 is 9. Oh, wait, no, that does work. Hold on. We say 2 plus 7 is 9. Length of 3. 7 plus 9 doesn't exist. Okay, that works, yeah. 7 plus 8. It's 15. Okay, 15 plus 8 is 23. That's 4. 23, 38, which doesn't exist. So 4 is max. Then we have 4 here. 4 here, 4 here. Where are they getting 5? What? Two plus 8 is 10. 8 plus 10 is 18. 1, 2, 3, 4. It's 28. 28 doesn't exist. Where are they getting 5? 2 plus 14. No, 2 plus 15. 2 doesn't work. This is 12. Nope. Nope. 4 plus 10 is 14. 10 and 14 is 24. No. 7 plus 8. 15. 8 plus 15 is 23. It's 38. How is this 5? Okay, 2 plus 2 and 4 is 6. There's no 6. 7, 9. That's the first valid one. That's 3. 13 doesn't exist. Okay, 2, 8 is 10. 18. But 28 doesn't exist. 2, 9 is 11 does not exist. 2, 10 is 12 doesn't exist. 2, 14, 16 doesn't exist. 2 doesn't. Okay. 4 and 7 is 11. Nope. 4, 8 is 12. Nope. 4, 9. Nope. 4, 10 is 14. Okay. 4, 10, 14. 24 doesn't exist. Okay. 4, 14 is 18. 32. 50. There's the value. 4, 14, 18, 32, and 50. 4 and 10. And current is based on these values. Oh, shit. And current equals array J. Oh, no, that should still be fine. 4 and 10. Why does this stop at 4 and 10? Yeah, 4, 10, 14 is fine. It breaks out. It should go to 4, 4, and 14. Why aren't you? I think this is why. Oh my goodness, that was a hard problem. Ooh, how long did it take me? 40 minutes. Not the most time efficient, but all right. It's kind of brute forcey a little. I kind of want to see what these people are doing. Map. Pair. Iterating through the array. They have a start and end. Okay. They use the left and right. It's kind of like two sum, right? Where they're going from both sides. Let's see what the editorial says. For loop, previous current length. Fine. Oh, wow. This is like identical to what I was doing. Well, I guess I found the brute force solution. All right. The DP solution was what I was trying to figure out. They had a map. They mapped the value to the index. Set current. Oof. Okay, well, that was the problem for the day. I hope you enjoyed my solution. I guess it was a little more brute force than I thought. Also, I need to use the constructors more. Oh well. Thank you for joining in, and I hope you have a wonderful day. Peace.